All righty. Hope everybody's doing great today. All right. So today we are going to be talking about chapter 5, which is your dynamics of uniform circular motion. And that's going to be for physics with algebra. And this is again going to be from Cutnell and Johnson book. Cutnell and Johnson book. So let's say you have a person. Let's say I got a person over here that's holding on to a ball wrapped around a string. Get red for the string. And of course, you got your ball going in your circular motion. Now, this is going to be our side view. Let's take a look at a bird's view. Let's say we call this the bird's eye view. So what you got? You got a ball going in. Let me go ahead and going in a circular motion. When this ball travels, there is going to be a force pulling towards the middle. And the same time will travel, the direction it will travel is going to be perpendicular to this force, which is your V. So when the ball is right over here, let's say this is your radius, so you got your force coming over here, and this one should be going to be perpendicular to the force going in. Same thing, let's say you got your ball over here. That means here's your force going inwards, and you got your velocity going perpendicular to that. Now, this force is going in is going to be called your centripetal force, and we're going to give it FC. So your centripetal force is a force, centripetal force, which is a force that points towards the center of circle. So this is the force that points towards the center of the circle. And again, let me just say our ball is right over here. It's the same concept. You got is pulling towards the center of the circle. I said this dot is the center of the circle. You got your FC pulling in this way, and you got your velocity, which is going to be perpendicular to that. So that's why it's going in a circular direction. So it's a force that points towards the center of the circle, which we call the centripetal force. Now, the centripetal force, this FC, centripetal force, is going to equal to the mass of the object times V squared divided by R. V, that's your velocity. M, that's your mass. And R is the radius. So the magnitude of the centripetal force equals to mv squared over R. And let me go ahead and sign this. This is your centripetal force. So out of this, double the mass What's going to happen with the force? That means you need, actually, let me do an equal sign. More centripetal force. If you double the speed, your speed is square. That means your centripetal force will quadruples. Let me go ahead and down. This is going to be quadruple the centripetal force. Now, if you double the radius, what's going to happen? It will have the centripetal force. So your centripetal force again equals to mv squared over r. If you double the mass, it will actually, if you double the mass, it will double the centripetal force. If you double the speed, it will quadruple the centripetal force. If you double the radius, it will make centripetal force in half. And that's what we just talked about. So our centripetal force is a center-seeking force. It's an inward force that exerts on an object to keep it moving in a circular path, which equals to mv squared over r. M is your mass, v squared is your speed squared divided by r, which is just radius of your circular path. And again, the greater the object's mass, the greater the centripetal force. The faster the objects move, the greater centripetal force. The smaller the object go in a circle, there's the greater centripetal force. The smaller the circle, greater force. The bigger the circle, the less the force is. So let's say we have this question over here. You got a 1,000 kilogram car traveling at 5 meters per second, makes a 30 meter per second, 30 meter turn. How much centripetal force do the tires supply? So, like in every question, we use my 4 rules. The first one, we write down the information. Maybe example 2.14. So your first piece of information was your mass, which was 1,000 kilograms for your car. Your velocity is 5 meters per second. Your radius is 30 meters per second. 30 meters. I don't know why I'm stuck on meters per second. And you're looking for your FC, your centripetal force. Where your centripetal force. So we got our knowns. We know what you're looking for. You write down the equation, which is mv squared over r. We're solving for centripetal force FC anyway. Go ahead and do all of these. So this is going to equal to your 1,000 times 5 squared divided by 30, which is 1,000 times 25 divided by 30. And you should get 833 newtons. Let's go ahead and check our work. And it's 833 newtons. Now let's say we have another question. Let's say we have a road that has a hump 12 meters in the radius. What is the minimum speed at which the car will leave the road at top of the bump? So right now we need the minimum speed that is going to. So in this question, example 2.15, you have your radius as 12 meters. And we're looking for your minimum speed that you're going in. Let me go ahead and write this minimum speed that you're going in. And all right. And now the third thing is we write down the equation. Well, your FC is going to equal your mv squared over r. Unfortunately, we don't have the mass. But what is FC? FC is a force, which is your basic unit of the force. is your mass times acceleration. Which one? What is the acceleration that is affected by it? Your acceleration is going to equal to your gravity, which is 9.8 meters per second square. So really, this centripetal force, which is your mv squared over r, is going to equal to your mass times your gravity. So your mass times velocity squared divided by r equals your mass times your gravity. Your masses cancel out. That means v is going to equal to your r, your radius times your gravity square root, which is in this case, it will be 12 times 9.8. And if we plug that in, we should get 10.8 meters per second. Let's go ahead and check our answer. And indeed, our answer is 10.8 meters per second. Now, going back to our little ball that's going in this circle that we had in the beginning. So, all right, now, let's go back to our little example. Again, like we said, the bird's eye view. So you got your little ball going in a circle, and you go ahead and do the circle. So you got, I can do it per circle. So here's your little ball that we have earlier. And we define this ball as you have a force, which is your centripetal force, headed towards the middle, which perpendicular to it is your velocity, v. And each way it goes in. Now, this velocity that we have, your velocity is defined as distance over your time now, which means that v is going to equal. Now, your distance that you're going, what is the distance? Well, apparently you're going towards the circle, you're going back over here, back in the circle. You're starting from one point, going around, and going back in the circle. So your distance is actually the circumference of the circle. So it's the circumference. Actually, down over here. So your circumference circle. Now your circumference circle is going to equal to 2 pi r. So your v is going to equal to 2 pi r divided by your time t. Now your time that we're going to be doing, we're going to give it a big letter t, which we're going to be talking about more in chapter 16 for the period. But your definition of that is how much revolution per time. Actually, let me go ahead and press the T over here. So how much round, how much one round, how much the time for one round. Is the time for one circle, or we can call it a revolution. So your V equals 2 pi r over t. T is the same as the time, it's still in seconds, but it's the time for one circle. How much the time for it to go in one circle? So let's go ahead and look at this example that we have. So let's say we have a question. A wheel of a car has a radius of 0.29 meters. It's being rotated at 830 revolutions per minute. Determine the speed which the outer edge of the wheel is moving. So this is called example 1 in my notes. I'm just going to stick with it. So our first piece of information in here is your radius, which is your 0.29 meters. And you're going at 830 revs per minute. Now, this 830 revs per minute is opposite of minutes per rev, or time per revolutions. So basically, this is going to be your 1/t. So in other words, what this means is for every 830 revolutions, for every 1 minute. How many minutes do we have? How many revolutions do we have for x minutes? Cross multiply. That means 830x is going to equal to 1. That means x equals 1/830, which is going to equal to 1.2 times 10⁻³ minutes. So from this one, your period is going to equal to 1.2 times 10⁻³ minutes. Multiply that for each 1 minute is 60 seconds. To convert it, so 1 minute equals 60 seconds. That means our period in seconds is going to equal to 0.072 seconds. So we got the radius, we got the information for the period, and we're looking for, let me get a different color. We are looking for your velocity. And notice that the velocity is going to equal to the circumference circle, 2 pi r divided by your period. So it'll be 2 times pi times your radius, which is your 0.29. Divide that by 0.072. And we should get 25 meters per second. That's what we got. Now, having to look at our little ball again that's going in a circle. So let's say here's my little circle again. And this is my ball that's going in a circle. And again, let's say this is our center of the circle. I'm just going to call it C. And you got your, let me get a different color. You got your centripetal force pulling in this way. Which is going to be, that's your radius. So let's say it's going in this way. And you have the ball was over there, and it becomes right in this side over here. So you got also your radius, which is according to that, that's your centripetal force. And let's say this is perpendicular to it. And this one will be perpendicular to that one. So let's say call this point, you're going from point O to point B. And you are going in this way. Now, having to do that, if you actually drop a line to make this into a perfect triangle, and you can call these two, alpha and beta. So let's say call this angle over here. You get your triangle going in. Let me actually go better. So let's say this is your beta, this is your theta, or your alpha. It's called alpha. Now, according to Lost Triangle, this is 90. And let me call I've not called this one yet. Let me call this one over here. Let me call this one theta. So according to our laws of triangle, if this was 90, that means your alpha plus theta is 90 degrees, which means that alpha plus beta is going to equal to 90 degrees. If you subtract both of them, what you're going to have? You're going to have beta minus alpha equals to 0. That means your beta is going to equal to your alpha. So taking these triangles, so here's your C that we got over here. Actually, let me just draw them this way. And this is the point O, this is your point B. Your traveling side is a curved path because you are going towards the circumference of the circle. Your velocity, if you actually check your velocity, so let's say your V1, this is your velocity at this side, this is your velocity at this side. That means it's going to be delta V. So this is your velocity at initial time. And this is your velocity at your final time. Actually, let me go ahead and redraw this better. Supposed to be a straight line. Yes. So you got a straight line, and you're going, let's say you're going this way. So from over here to over here, that's your distance D, which your V equals your D over T. That means your distance equals V times T. So this is going to equal to whatever velocity we have times whatever time you go in. And I'm going to put delta T because we're going from T final, T initial. This is your velocity at T final. So according to laws of triangles, your delta V over V is going to equal your dV, not dVt, your V delta T over this line, which this is a line is your radius R that we talked about. Which means if we actually take this, we have dV over dt, we have rearranged this, what do you get? We get V squared over R. Now, what's your velocity? Your change velocity over change of time. That's going to be your acceleration. Let me actually get a different color of it so y'all can see it better. Which in this case is centripetal acceleration. So this means that your centripetal acceleration is going to equal to your V squared over R. So your centripetal force is going to equal mv squared over R, and centripetal acceleration is going to equal to v squared over R. V is your velocity for this little fella, R is the radius for this little fella over here. And of course, M is your mass. FC is your centripetal force. and AC, that's your centripetal acceleration. So looking at a question, bobsled trash contain turns with radius 33 and 24 meters. Find the central force for each turn at the speed of 34 meters per second in terms of multiples of G. So going in, our example 3. Your R1 equals to 33 meters. R2 equals to 24 meters. Your speed is 34 meters per second, and you're looking for your acceleration and G in gravity. All right. So you know our acceleration is going to equal to your V squared over R, which means that AC1 is going to equal to your V squared over R1. Your AC2 is going to equal V squared over R2. So this is going to equal to your 34 squared divided by 33, and you should get 35 meters per second squared. If you divide that by 9.8, you should get 3.6 times G, your gravity. And you get a different color on this, so one clash, you get a black one. So AC2 is going to equal to V squared over R2, which is going to equal to your 34 squared. Divide now, second radius is 24. So you should get 48 meters per second squared. Divide that by 9.8, and you should get 4.9 times G. Notice for a smaller radius that the acceleration was higher than a bigger radius. And that's what we saw. We saw when F equals also MA. And, you know, we talked about where your acceleration is your summation of all the forces in X and Y, and Z direction divided by your mass. And so the centripetal force, which equals to mass times your acceleration. In this case, the centripetal acceleration, which is going to equal to mv squared over R, because again, your AC is V squared over R. So let's see another example, shall we? Let's say my airplane has a mass of 90 kilograms, and that goes in a circle. Find the tension in 17 meters, guideline of a speed of 19 meters per second. So your mass, let me go ahead, example 5. Your mass is 0.9 kilograms. Your distance, or the radius, is 17 meters, and your velocity is 19 meters per second. And you're looking for your tension, which in this case, the tension is going to be centripetal force. Because again, your tension is a force, and your centripetal force is mv squared over R, which is going to equal to 0.9 times 19 squared divided by the radius, which is 17. So you should get 19 newtons. Let's check if our answer is correct. And it is correct. Now, when you go on a curved path, let's say you got your car, let's say you are going on a curved path. Let's say you're going on a curved path in your vehicle. Let's say this is my vehicle, so I'm just gonna go. So I roll the back a bit. Wheel over here, here's a wheel over there, going this way. So here's your car, and this car is going in a curved path. Now, according from chapter 5 that we saw, your trajectory, which we're gonna do over here, is going this way. And that's gonna be your normal force, which is gonna be perpendicular. Actually, let me write that better. Get different color. Let me get a different color. Let me get green. So this is going to be perpendicular to the line where it's at. So this is going to be your normal force, which is going to be a cancellation of your F normal in the x direction, which is going to be your normal force cosine theta. Should be a different color of this. And this is going to be your F of y, which is your F neutral. Which equals to F and sine theta, which we saw that from chapter 1. Now, opposite of that, you have your weight, which is going to go opposite of your F in the x-axis. So going in this way, you're going to have your weight, which is your mass times your gravity. And of course, this is creating an angle theta. Now your centripetal force which is your mv squared over r. You are going in this curved path over here. You're turning into this curved path over here. So this is going to have to equal to Fn sine theta. Fn sine, I'll change color. Fn sine theta. And from this one, your Fn cosine theta is going to have to equal to your mass times your gravity. So you got your, let me go ahead and write this down over here. So you got your Fn sine theta is going to equal to mv squared over r. And your Fn cosine theta is going to equal to your mass times your gravity. Out of these two, if you actually calculate tan theta, it's going to equal to v squared over rg. That means the angle is going to equal to inverse tan for v squared over r times your gravity. So let's go ahead and see this question. So example 8, what we got? We got 360 meters for the radius, and you get a 31 degrees. What speed would you need to look for the speed that it's traveling around them in order to maintain the track? Okay, so We go open up a new one, new slide. This is example 8. Your radius is 316 meters, and your theta is 31 degrees. And you're looking for your velocity. And we know that tan theta that we just said is v squared over rg, which means that v is going to equal your tan theta multiplied by rg square root, and that's going to equal to square root of 316 times 9.8 times your radius, which is, I'm sorry. Let me go ahead and write it down. Tan 31 times 316 times your 9.8, and you should get 43 meters per second. Let's go ahead and check. 43 meters per second. Now, there's only one speed that the satellite can have if its satellites remain in orbit around a fixed radius. Now, if you have a satellite going around, so let's say this is our Mother Earth over here. And you have an object, kind of like we had our balls. Let's say this is our satellite over here going in an orbit. The centripetal force of the satellite is going to equal to mv squared over r, which is going to equal your gravitational force between both of them objects, which is going to equal to g m of the satellite, and I'm going to go me, that's your mass of the Earth. Divided by square the distance between them. So your m v squared over r, the satellite, and this is going to be for your satellite. Which is this little m over here. So your mv squared is going to equal to g m me over r squared. Both masses cancel out, and when the radius cancel out, solving for the velocity, you're going to be equal to the square root of the gravitational constant g times your me divided by r. So let's say we have a question. Different speed of the Hubble telescope orbiting the height of 508 kilometers above the Earth's surface. Each Earth radius is 6.38 times 10, 106 meters. So let's go ahead and do this one. This is going to be your example 9. So your height is 598 kilometers. And your radius is 6.38 times 106 meters. Now I'm going to go ahead and write down the mass of the Earth, which I didn't write down over there. Let me actually go ahead and write it down over here. This is going to be 5.98 times 10 to the 24 kilograms. And we go ahead, 5.98 times 10 to the 34, the 24 kilograms. And your radius 638 times 10 to the 6 meters. It was actually a mistake, times 6 centimeter. Now we're gonna add that, we're gonna add to that your height, which is 598 kilometers. Actually, I'm just gonna add them both on the equation itself. So let me just go ahead and put them down. So your radius is gonna be that much. Your mass of the earth, and you get your height. You're looking for your velocity. And you know your velocity is gonna equal your square root of the gravitational constant times the mass of the earth divided by the radius, which is gonna equal to your 6.67 times 10 negative 11 times your mass of the earth, which we defined as 5.98 times 10 to the 24. Divide that by your 638 times 10 to the 6 plus your 598 times 10 to the 3. Now in this case, you should get 7.56 times 10 to the 3 meters per second. And that's your velocity that the satellite will orbit around the Earth. And that should conclude chapter 5 for Cutnell and Johnson book. If you have any questions, please email me at abunaemeh@gmail.com. Thank you so much. This is Dr. Malek. Have a nice day.